Welcome back everyone to Data Science for Everyone. Today we're going to be looking and continuing our lessons on simple linear regression from our noisy data segment onto some unsorted data. Let's get started. So again, we've been talking about approximation and being able to create up some very basic linear regression again with noisy data or with unfitted data, those types of things. So this is our basic outline that we've been needing in here, and so we have in here import numpy as np, matplotlib is plt. We want our matplotlib inline so we can use it with Jupyter notebooks. We have some basic line space data in here because again we're going to be using some sort of sign function to kind of mimic some financial data right now. Again, we're doing the very basics now and we're going to be building ourselves up. Now we also need to make a simplification function for plotting, so then we don't have to do things over and over and over again. There are other ways that we can do this, but again, we're just going to do this and keep it kind of nice and simple for now. So let's go back and kind of talk about some unsorted data. And again, some important aspects about regression is that the approach works seamlessly with unsorted data as well as with our noisy data. Now, we've relied on some sort of sorted X value previously. Now, this does not necessarily have to be the case, okay? Again, we've been using this nice kind of structured data, as it were. So to make this point, let's actually grab another completely randomized approach to our X values, okay? So instead of using something like this, let's actually create up a little bit of something a little bit more noisy, let's say, a little more random. In this case, so let's comment that out and let's actually create up something else. So xu for unsorted mp.random.rand the 50 multiplied by 4 multiplied by mp.pi minus 2 multiplied by mp.pi. And then y in this instance is, actually let me move these. Let me run this and I'll put the data creation down here. So here would be something like fxu. So then we actually have that nice data in there. So let's take a look at the actual data. You know what? I'm not really going to because that's going to be for you guys. I didn't put in a random seed so that you guys would have the same data as me. So I'm not going to worry about showing you guys the data. But let's go in and just do the basic regression in here. So mp.polyfit xu, yu, and a 5th degree polynomial for this. Our y is going to be our mp.polyval. With we want in here our regression and our xu for this data. And we can also go on and create up our basic plot in here of xu, yu, comma, ry. And here we want in b dot. So a blue dash, I don't actually like that. Let's just do this, and I want to keep it everything kind of generalized. Our dot, and then in here we want f of x, our 5th degree regression, and then we want what? In here we want x-axis label and our f of x to be our y label. Oh, that does not look right because again it is unordered. This actually does need to be this dot in here, and you can see them. This makes me a little bit dizzy, so maybe instead of these, let's make this an O, make it a little bit bigger. So here we can see that we have our actual values. Again, this is similar to our previous examples of having some noisy data. Now, the regression approach does not care for order, okay, of our observation points. This becomes more obvious again when we're looking at whenever we're maybe minimizing some data And again, we'll see those a little bit later on as well, particularly in some other examples that we've had in the past. Again, this is just a kind of a quick snippet of what we've been working on, and we're going to do a little bit deeper dive later on. The next video, we're going to be talking about multi-dimensional data. If you guys want to see more stuff like this, please comment, subscribe, and hit that like button, and I will see you guys next time. Bye-bye.